Hi students, in this video I am going to discuss with you regarding periodic classification of elements, previous years AIPMT and NEET examination questions. So for every competitive exam, the previous examination questions preparation is very important. That's why I have taken this topic. Okay. So in 2019, the first question given is for the second period of element correct increasing order of first ionization energy. So it's a very important one. What are the elements that are present in the second period? So that is starts from lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Okay, neon also they included. Yes, neon. So usually in a period elements from left to right the ionization energy values are increases because the ionization energy is inversely proportional to atomic size or atomic radius. So that means in a period from left to right atomic radius is decreases. That's why ionization energy must be increased. Neon case it is a noble gas configuration, completely filled electronic configuration. That's why it has high ionization energy. Anyway, but here some abnormalities are there. That is between beryllium to boron and nitrogen to oxygen. So usually the beryllium is having high ionization energy than boron, and then carbon and nitrogen also having high ionization energy than oxygen. Because of the reasons for beryllium high ionization energy, it has a 2s2 completely filled s orbital, and nitrogen is having 2s2 2p3 half filled p orbital configuration. Because of that reason, so it has a high ionization energy value. It's stable configuration. Okay, see the first option, lithium to beryllium to boron. Beryllium has high ionization energy than boron. It's wrong. The second option, also the same. It's wrong. Third option, yes, beryllium is having high ionization energy than boron. But the next one is nitrogen is also having high ionization energy than oxygen. Yes, this order. Then see the fourth one. Okay, here nitrogen is having less ionization energy than oxygen. It is wrong. That's why the answer is third one. So it is very important one, students. Okay, the next one is when magnesium reacts with an element X to form an ionic compound. If the ground state electronic configuration of X is 1s2 2s2 2p3. So they have mentioned the ground state configuration 1s2 2s2 2p3. What is the atom that represents that electronic configuration? That is nothing but nitrogen. Okay, so if it forms an ionic compound, they mentioned that ionic compound, if nitrogen forms an ionic compound, it forms nitrides. Okay, when nitrogen involves in an ionic compound, so what is the compound is formed is nitride. Nitride means N minus 3. Okay, so the next one it is X. They mentioned X nitrogen, and it forms an ionic compound. They mentioned. So magnesium, you know that magnesium is a second group element, so it forms a 2 plus. And nitrogen, if it forms an ionic compound, it forms 3 minus nitride. So what will be the compound formula is just cross multiply the charges present on that. That is Mg3 N2. Okay, so that is Mg3 X2. Okay, so the next question is, so they mentioned the atomic number 114. So what will be the family of the element? Okay, so here they mentioned the nitrogen family, halogen family, carbon family and oxygen family. So it is very easy to write down if you know the atoms in group wise. First, what are the options they have mentioned? Carbon family. What are the elements? Carbon, silicon, germanium, tin and lead. Okay, next nitrogen family. Nitrogen, phosphorus, arsenic, antimony and bismuth. Next, oxygen family. Oxygen, sulfur, selenium, tellurium, polonium. Next, halogens, fluorine, chlorine, bromine, iodine, astatine. Okay, so these are. So then we can write down the atomic numbers. What is the atomic number for carbon? It is 6. Okay, next one, silicon 14, germanium plus 18 you can add 32, next 18 50, next 32 82. But they have mentioned the atomic number is greater than 100. So the next one also it has you need to add one more 32. Okay, so that means 114. So that means which atom, that means the atom belongs to which family, that is the carbon family. So you don't require the configuration, you can find out this is 86, then you can find out 114. So it is the easiest way. So you can write down the atomic numbers 7, 8 and 9, this one, okay. And the next one is phosphorus 15, sulfur 16 and 17. The period elements are 33. Next one is 34, 35. Next 51, 52, 53. Next 83, 84, 85. If you require the next element, just add 32, 32, 32 for all. Okay, that means very simplest way. So by this way you can find out the configuration or maybe group number for an element. Okay, so the next question is, in which of the following options the order of arrangement does not agree with the variation of property indicated against it? That means they have mentioned some orders. In these orders, which order is not correct? You see the electronegativity of halogens. We know the electronegativity of halogens case. Okay, so electronegativity is no exception. So fluorine is having highest electronegativity than any other halogen. So that is the order is the correct one. Okay, next one, metallic radius. Metallic radius or maybe atomic radius in a group elements from top to bottom. So lithium, sodium, potassium, rubidium, all of the same group elements. So it increases. Okay, so that is also correct one. Next one, ionic size. See there, here the cations are there, here is the anion is there. Always the isoelectronic species they are. So anion is always bigger than the cation. So anion is bigger. But with respect to the cation, with the increase in the charge, size decreases. Okay, it follows the correct trend. So this is also correct one. So boron, carbon, nitrogen, oxygen. This is already we discussed just before. That means nitrogen is having high ionization energy than oxygen. So this is the wrong option. Yes, next one is this is oxygen. If it gains one electron, it forms oxygen minus. This is an exothermic reaction. Then oxygen minus, the whatever the ion is formed, that gains one more electron, it forms oxygen minus 2. Okay, so the next one is, it is an endothermic reaction. They have mentioned in the question. Thus, the process of formation of oxygen minus 2 in gaseous phase is unfavorable. They have mentioned that it is unfavorable. This reaction is not favorable because even though oxygen minus 2 is an isoelectronic with neon, that means oxygen minus 2 is having noble gas configuration, even though the formation is unfavorable because of the reason they are asking. Okay, so the reason is, see here, oxygen is already having negative charge. So we are adding the electron to the negatively charged species. So that's why oxygen is more electronegative. That is not reason. Addition of electrons to the oxygen gives the larger size of the atom. That is also not reason. Electron repulsion outweighs the stability gained by the achieving noble gas configuration. That means, so even though it gets stabilized by noble gas, getting noble gas configuration, that will overcome by which one? This is the electron repulsions are more compared to the stabilization gained by the oxygen minus 2 configuration. That's why it becomes unfavorable. That is the option. Okay, so among the elements, which of the following electron configuration, which one of them may have highest ionization energy? See there, here they have mentioned neon 3s2 3p1, 3s2 3p2, 3s2 3p3. So that means those are present belongs to the same period elements. Okay, 3s2 3p1 and 3s2 3p2 and then 3s2 3p3. And the next one is 4s2 4p3. That means belongs to same group elements, these two. So neon is there automatically. So in a period elements, the electron ionization energy should increase. Ionization energy, yes. In a period elements, usually from left to right, what happens? Atomic size is decreases, so ionization energy increases. So even though it has a stable configuration, so that's why it has highest ionization energy. What happens in a group elements? From top to bottom, the ionization energy decreases because of increase in size. It is a third shell, it is a fourth shell. So removal is easy than compared to third shell. So that's why which one has the highest ionization energy is the stable configuration as well as the period elements. It increases from left to right. So in a group elements, 4s2 4p3 also stable configuration, but In a group element from top to bottom, it decreases. That's why this is the answer. Next one. So, which of the following represents ionic radii is correctly represented? That means they have mentioned that which one is the correct representation. So, you have remember that always the cation is smaller. Okay, if you have cation, neutral atom and anion for the same species, what is the sizes variation is, for example, neutral atom, they have mentioned hydrogen, anion is always bigger. That means H minus is always bigger than neutral atom, but neutral atom is bigger than the cation. Okay, so you have to remember that anion first, then neutral atom for same species, neutral atom and then cation. So it is the perfect order. Okay, so that means the first one is correct one, because the negative charge anion first, then neutral atom and then cation. See the second one. So with the cations not always bigger than the anions, it is wrong. Next here, anion case, yes, anions are bigger than cation, but in case of anions, charge increases, size increases. That means this is the bigger one, not this. When this case, cations case, cations are not bigger than anions, so this is also wrong. Okay, so next one is which of the following has electronic configuration argon 3d6? So that means they have mentioned some ions. Which ion is having argon 3d6 electronic configuration? See the first one, cobalt. Cobalt atomic number is 27. That means you can write down argon 4s2 3d7. It is very easy to write down the configurations. 27 it becomes 4s2 and 7 becomes 7. But chromium and copper doesn't get such type of hint configuration. It's very easy to remaining except chromium and copper. If you know the atomic number, you just divide 2 for 4s and next number is for 3d. And then it is 4s to 3d7. Then for cobalt plus 3. That means in case of, you have to remember, we have to remove the 3 electrons from this configuration. So in d block elements, first we have to remove the electrons from 4s. And then the remaining electrons can be required, whatever may be required, that will be removed from 3d. Then it becomes 4s 0, 2 electrons removed, 1 more electron is removed, then it is 3d6. So the first option. What about the nickel? Nickel configuration is atomic number is 28. I told you just before. So you can write down the configuration 4s2 3d8 2 8. Then becomes nickel plus 2. That means it becomes 3d8. Okay. So the next one is manganese. They have mentioned manganese. Manganese case 25 atomic number. We required argon 4s2 3d5 2 5. Okay. Plus 3 means so 3d4. Iron atomic number is 26. It is 4s2 3d6. 3 electrons have to remove this 2 from here and 1 from, it is 3d5. Okay. So 1 is 3d4, 3d5, 3d6, 3d8. They are asking argon 3d6. Which one is the cobalt? Yes. Next one is similar. That's why the sizes of isoelectronic species is very, very important with respect to NEET and AIPMT. So AIPMT is over, but anyway, so present NEET examinations. So ionic size, that means isoelectronic species, the sizes are very important. We can see so many questions are related to this one. So the correct order of decreasing ionic radii among the following isoelectronic species. So what are the species they have mentioned? I will write you separately the species they have mentioned. First you have to separate the anions and Cl minus and the cations, K plus and Ca plus 2. So see this first one. So always anions are bigger. That's why we separated first anions. Okay, always anions are bigger. So they are asking decreasing order. That's why we have to start for bigger. So always the anions are bigger than the cations. So this one are bigger than this one. In case of anions, greater the charge or greater the charge is greater the size. So S minus 2 is greater size in than Cl minus. Next one. So anion is always bigger than cation. In case of cations, greater the charge, size decreases. That's why K plus is bigger than Ca2 plus. So this is the order. So this which one? S minus 2 Cl minus K plus. So this one is the answer. Yeah. Okay, the next one is which following represents correct increasing electron gain enthalpy? So what are the atoms they have mentioned? Oxygen, sulfur. Okay, same group. Fluorine and chlorine. Same. Four elements they have comparing here. So these are one group, these are one group. You know, electron gain enthalpy or electron affinity. What happens in case of electron affinity? Electron affinity is what happens with the size. Size decreases in a period. Size decreases. Electron gain enthalpy is increases. Electron gain enthalpy is increases. So compared to oxygen and fluorine, which one has a high electron gain enthalpy? Fluorine has high enthalpy. But what happens in the group case? Second element is having high electron gain enthalpy than the first element. It is the exceptional case. So chlorine should have high electron gain enthalpy than fluorine, and then sulfur is having high electron affinity or electron gain enthalpy than oxygen. So among these four, which one has the highest? Not only among these four, in overall the periodic table, chlorine is the highest electron gain enthalpy element. So that's why we can skip these two options, because of sulfur or fluorine doesn't have. Chlorine is having highest electron gain enthalpy. So after chlorine, fluorine, then sulfur, then oxygen. So this is the answer. Okay, so the next one is which of the elements with the following outer orbital configurations? So configuration that exhibits largest number of oxidation states. So how can you find out the largest number of oxidation states is the minimum oxidation state is that is equal to the number of electrons present in ns orbital. That means how many electrons are present in 4s? 1 2 1 2 2. That means the minimum oxidation state is +2. So the maximum oxidation state can be calculated. Maximum, how can you calculate the maximum oxidation state shown by an element? That is equal to number of electrons in ns orbital plus number of unpaired electrons in n-1 d orbital. This is the formula. Based on that, you can calculate what is the maximum oxidation state of an element. See this one. So this is so 3d3, 4s2, 3d3. So 4s2, 3d3. So I am writing 3d3 configuration 1 2 3 4 and 5. 3d3. This is a 3d3 configuration. So the maximum, I am just calculating the maximum oxidation state. So number of electrons present in ns orbital is 2 plus number of unpaired electrons, single electrons, 3. That's why this one has shown, so plus 5 is the maximum oxidation state. See the next one. What about 4s1, 3d5? So 3d5 I am writing here. Okay, 1, 2, 3, 4 and 5. So here number of electrons present in ns orbital is 1 and then plus 5. Number of unpaired electrons in d orbital is 5. So that is equal to maximum oxidation shown by this one is plus 6. Okay, next one. 4s2, 3d5. So 3d5 is same. 1, 2, 3, 4 and 5. Okay, that is number of electrons in ns is 2 and unpaired electrons in d orbital is 5 plus 7. Then last one. 4s2, 3d2. So 2 plus 2, that is plus 4. So which one shows highest oxidation state? That is 4s2, 3d5. So you can find out, this is the formula to use to calculate what is the maximum oxidation state shown by the d block elements. It's a very important one. Okay, the next one, which of the following atom shows the lowest ionization enthalpy? This is very easy to find out. See how many. This is a stable configuration, this is stable, and okay, this is also, but here how many number of shells are there? This is the biggest atom. Ionization energy is inversely proportional to atomic size. Okay, so how many shells are there? Here 2, here 2, here 2, but this one is having 3 shells. So that means atomic size is bigger for this one, so it has a lowest ionization energy. Otherwise we can easily remember that the first group elements or 1A group elements are usually having lowest ionization energies, because after the removal of one electron they can attain the noble gas configuration. That's why they are ready to lose one electron and get stabilized by the noble gas configuration. Okay, so these are the total AIPMT and NEET examination questions, student. So subscribe my channel and I will update you. That means so many chapters and also most important discussions I will continue in my channel. Okay, thanks for watching.